Good morning. In this case study, we are discussing about the theory of physics. So first of all, we know that the theory of physics is a combination of it's like a kinematics and dynamics. Okay. So before today class, we are discussing about the kinematics topic under the different types of mechanisms. So these mechanisms is called as the Fober mechanism and the coagulator, that is called as Fober mechanism, and Snyder crank mechanism and double Snyder crank mechanism. That is not will be explaining how is this Snyder crank mechanism is working, and also different types of like surveys and Ananya will explain how is it working and application, the case study and the problem statement also we explain in this case study. Thank you.
So myself Nishan, and I'm from third year mechatronics. So I'm going to explain the introduction part of Snyder crank mechanism. So the Snyder crank mechanism is primarily used to convert rotary motion to reciprocating motion or vice versa. We often see this mechanism in action in internal combustion engine, like those in the cars and bikes. The basic setup involves a crank and a slider connected to a connecting rod on a single plane. As for the crank, as the crank rotates, it pushes and pulls the connecting rod, which in return goes back and forth. So the mechanism is essential because it forms the heart of the engines, pumps and compressors. Understanding it helps us to grasp how the engines generate motion through fuel, which is the backbone of transportation and industry. Next, Sarvesh will talk about it.
So much is service. So now we are going to see the components used in the mechanism. So first is, from the name you can understand there's a crank. Crank is used to rotate the provided input, and the connecting rod. Connecting rod is used to transmit the motion from the crank to the piston. So next the slider, or also known as piston. It moves linearly with the cylinder, and the frame. The frame is the mechanical housing of all these components. And this case study has a context, and the context of the case study is in a 4-stroke petrol engine, the slider crank is used to transfer the energy from combustion, that is the reciprocating piston motion, to usable rotational motion at a crankshaft. It operates through intake, compression, power, and exhaust strokes. The engineering parameters: crank radius is 50 mm, connecting rod length is 150 mm, the piston displacement is approximately 100 mm, and the operating speed is approximately 2000 rotations per minute.
Hi, I'm Ananya from third year mechatronics, and I'm going to talk about application of slider crank mechanism, internal combustion engine, compressor, pumps, shaping mechanism, automated machinery, and textile machines.
Hi, I am T. Srinidhi from third year Mechatronics Engineering. Here, the question is, a crank and a slotted lever mechanism has the following data. Crank OA has 60 mm, connecting rod AB has 200 mm. The crank rotates clockwise at 120 rpm. Angle between OA and the horizontal is 60 degree. Find, the first one is velocity of point B, and the second subdivision is angular velocity of AB, and the third subdivision is draw velocity and acceleration diagram. Here, the solution of the first step is to convert the units. So, the OA value is 60 mm. We have to convert it into meter. So, if we convert, the answer is 0.06 meter. AB is equal to 200 mm. If we convert 0.2 m, and the speed n here is 120 rpm. Here the angular velocity will denoted as omega. Here the omega OA is equal to, the formula of omega is 2 pi n by 60, which is equal to 2 pi, the value of n here is 120. So 120 divided by 60, which gives 12.57 radian per second. And the second step is to find a velocity of A. The velocity of A value, to find the formula is omega into the actual value of OA, which gives 12.57 into 0.06, and the answer is 0.754 meter per second. The direction here we given as perpendicular to OA, and the step third is angular velocity of AB. VAB is equal to omega AB into actual value of AB. Here the value of omega AB is equal to VBA divided by AB. this is the velocity diagram of the given sum. To find the acceleration diagram, the centripetal of acceleration A is equal to omega square into OA, which if we substitute the values 12.57 whole square into 0.06, which gives 9.45 meter per second square. From the formula, the value we found are velocity of B, which gives 0.95 meter per second, and the angular velocity of AB, which gives 4.75 radian per second, and the acceleration of B is equal to 14.5 meter per second square. And from the given values, we draw a acceleration diagram. Thank you.